Hello, everyone. We continue our discussion of statistics, and this time we are going to be focusing on the center of data. And sometimes this is known by the measures of the central tendency, or what's happening at the middle. The word middle here could mean different things, and we are going to see that to have an idea about the middle of the data, there are actually about four measures that we can take to have an interpretation or to have an idea of the middle of the data. So we will learn how to calculate the mean, the median, mode, and mid-range. And all these things are different types of averages. So that's why I told you before, when you say the word average in statistics, it does not mean necessarily the average as we all know it, like which is the sum of the numbers divided by how many of them. That's actually called the mean. The median, it's a type of average. The modes is another one, and the mid-range. We also be talking about percentiles and quartiles. We are going to be focusing more on quartiles. Okay, so an average is a number that is representative of a group of data, which is the middle of the data. There are at least four different averages, like I told you: the mean, the median, the mode, and the mid-range. And each of those four statistics are computed differently. Otherwise, we won't have four of them. And each will result in a number near the center of the data. That's what we call. That's why we call those measures of central tendency of the data. So let's start with the first one. The mean, sometimes denoted by X bar, is just like, let's say, suppose I have scores of a test. If I gave a test to a class of one of my classes, let's say 28 students, how can I compute the mean score? The mean score is the sum of all the 28 scores divided by 28. So in general, the X bar is the sum of the X's, the sum of the data divided by N, and N is the size of the sample, or N is the size of the population, or the size of, or how many numbers we have. As you can see, when we talk about those averages, we talk about the mean. Let's say particularly here, we need to have numbers because you cannot add something else besides numbers. So what's going to be the mean of those numbers? 30, 21, 51, 37, and 51. Just add them all together and divide by how many of them. So how many of them have 1, 2, 3, 4, 5? So it will be, add them all together, get 190 divided by 5, which is 38. And of course, the final result is not always a whole number. We could have gotten 38.9 or 38.7 or something like that. And we still call that the mean age or the mean score, whatever type of data you are dealing with or type of numbers you are dealing with, to be precise. Now, what is the median? The median is the one of the collected data. Well, not always. It depends. If the numbers that you are collecting is the number of them is odd. For example, you have 5 ages or 7 scores or 11, let's say, ages again, then what will be the median? Will be the number, the age, the score that is at the middle. So you need to sort the data, you need to sort the numbers, and the one sitting at the middle is the median. But if you have an even number of numbers, an even number of scores, an even number of ages, then you don't have that middle number. What would you do? You take the average, or you take the mean, or the sum of the middle two numbers and divide by 2. You will see this in an example. So rank the data from smallest and largest, like I told you. So we go back to the same example we did before. I think those are the ages of some people. So what will be the median? Well, as you can see, how many numbers we have: 1, 2, 3, 4, 5. So we have an odd number of numbers. 37, which is sit in the middle, that's your median. So 37 is the middle, so therefore it's the median. Now, if we took this example, 7, 8, 8, 8, 9, 10, as you can see, we have 6 numbers. So we don't have that middle number. So what would you do? You take the sum of the middle numbers. Well, here it happens to be 8, both of them, but it's not always the case. Whatever 2 numbers you have at the middle, you add them and you divide by 2, and that the median of your distribution. So same thing here, we have 8 pieces of data. So you pick 12 and 14. Be careful. You need to sort them first. You cannot just go and pick the middles numbers. They have to be sorted. And you take 12 plus 14 and divide by 2. And 13 will be the median of this distribution. Well, the same thing for this one. You will 8 plus 8. I told you that before. Divide by 2, which is 8. That's your median. Now, what is the mode? The mode is the piece of data that occurs most frequently, that occurs the most. And we go back to the ages, we had the 5 ages. 51 is the mode, because let me go back to those ages. Where are those ages? Give me 1 second. Here are ages. What is the age that is appearing the most? Well, 51 appears 2 times. The others appears just once. So 51 is the mode of this distribution. But now what happens if none of them is repeated more than once? Well, then you can just skip this mode. It will be irrelevant to talk about the mode, because every number actually is the mode, and that defeats the purpose. Because if something brings you back to consider every other number, every number collected, then might as well just drop that statistics. So we were at the slide with the mode. So that's right. The mode we said is 51 is the mode because it occurs twice. The mid-range, you may be interested in mid-range, means is just the average or the mean of the very lowest and the very highest. You just add the lowest number obtained to the highest number obtained and divide by 2. And the number that you get is called the mid-range. So lowest value, highest value, add them together, divide everything by 2. In my example 1, so 21 was the youngest age and 51 is the largest number, largest age. You add them together, you get 36 years old. That's the mid-range. Well, now we jump to something else called the position. For example, you would like to see or to have an idea about a piece of data, what is its position among the other numbers obtained. For example, a score of a student, in which quartile, in which percentile. So we have 2 things to use when it comes to the position of a piece of data obtained. We have what's called percentiles and quartiles. The idea of the percentile is, first of all, we have 99 percentiles, dividing a set of data into 100 equal parts, 0, 1, 2, all the way to 99, or 1. We start with the 1 percentile, 2 percentile, the 2nd percentile, 3rd percentile, and so forth. The idea is what? A score is in the nth percentile, for example, the 5th percentile, the 87th percentile, means if that is your score, means that you outperform, means that you did better than the nth. For example, if I obtain a score and I am at the 58th percentile, means I did better than 58% of the population. Well, it also means that 100 minus n percent did better than me. So you may use that as to have an idea about your position or the position of any number obtained among the other numbers. The quartiles are, I think, maybe more used than the percentiles. In the quartile, the word quartile refers to 4. So you are going to sort your data and divide your data into, well, you stop at the 25th percentile and you stop at the 50th percentile, which is the median, and you stop at the 75th percentile. So you are going to locate 3 or 4. At the end of the day, you'll be dividing your numbers into 4 zones. And then those 4 zones are delimited by 3 numbers. We call them the quartiles, the 1st quartile, the 2nd quartile, and the 3rd quartile. And the 2nd quartile is nothing but the median, of course. So how does it work? Well, it is a better pictorial orientation. So you sort your data. The quarter of the numbers, you put them first. So quarter of the numbers. And then you get your 1st quartile. And then you add the next quarter. So from the beginning all the way till here, you have half of the data. And Q2 is the median. So practically speaking, how can you find Q1 and Q2 and Q3? Well, Q2 is just the median. Then once you find the median, have all the numbers that are less than the median. Then find the median of those. That would be Q1. The numbers that are greater than the median, find the median of those. That would be the third quartile, as simply as it sounds. So like I said, order the data from smallest to largest, find the median, which is order second quartile, and find the quartile, and find the median of the numbers lower than the quartile, that should be Q1, and find the median of the numbers that are bigger than the second quartile, bigger than the median, and that would be your Q3. I hope I have like an example here. Oh, here is an example. That's good. So the very first thing, we need to sort the data. As you can see, the data is not sorted. If you sort the data, you should find something like this. Okay, this is the same data. As you can see here, just by inspection, I can tell that 17 is the median. So 17 will be Q2, the second quartile. What does this mean here? It means that you have 50% of the data less than 17, and also you have 50% of data that are greater than 17. So 17 is sitting at the 50th percentile. It means 50% of data is less than 17, and 50% of data is greater than 17. If those were like costs, and then you can just interpret that depending on the context in which you're using these numbers. Now, the numbers that are less than 17, which are 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, those numbers, I'm going to look at them just by themselves and find the median of them. Well, finding the median of them, that would be your Q1. Well, how many numbers are in there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13. We have an odd number of numbers, so it's easy to get the median. So the median would be 7, I think. Or would be 13. Let's see why I picked 7. Because so if you have 13, it means that we have 6, and the one at the third side will come 1, 2, 3, 4, 5, 6. Yeah, 9 is the middle of them. So therefore 9 is Q2. And we'll do the same thing for Q3. So second quartile, the median 17, first quartile is 9. And you using the same procedure for the numbers above the median, and that would be your third quartile. It's pretty easy. It's really not hard. And this is, again, just when you compute the mean, the median, the mode, just to have an idea about the center of data. And you would be interested in the quartiles or the percentiles just to have an idea about a piece of data. Where does it fit among the rest of data? I hope that was clear. Well, if not, please let me know. While doing the homework, like I always say, there are videos there, there's examples that will help you understand things better. But if not, I'm just an email away or call away. Just let me know, please.